Hello, everyone. Thank you for joining us today's episode of Delivery Experience Series. I would like to begin introducing myself really quick here. My name is Mete, and I'm a Senior Product Manager at Trendyol. And I've been working almost 5 years in Trendyol, and I'm very excited to be part of this event today. So let's get the ball rolling really quick here. So I would like to begin with what is TBP. So TBP is in-house platform product that was grown out of a concept of the idea of internal developer platform. So basically, necessary technologies and tools of a platform engineering have been bonded together to pave a golden path for developers' experience and day-to-day life. So basically, our main objective, creating this platform product, so-called TBP, is to lower the cognitive load across the technology department and enable developers to operate in a self-service manner while abstracting all kinds of lower complexity related with application delivery or infrastructure needs. So basically, in Trendyol we follow a platform as a product approach, where the platform engineers build, maintain, and continuously improve the experience while following product management principles and best practices. TBP allows developers to maintain fewer YAML lines, YAML files, and much fewer lines of code in their YAML files, basically. So this is one of the benefits. The second other benefit is TBP product was actually designed and built based on the needs of our technology organization. So with that being said, TBP flows and approaches are always considered and built around our organization's best practices and needs. This way, we kept the consistency across the whole organization during the infrastructure provisionings and application deployments, and also we achieved the maturity with that. Um, I would like to move on to the next slide really quick. So basically, TBP is part of what we call the application plane, and um, it provides a full abstraction, as I mentioned earlier, to hide all low-level complexity from developers. That's the main objective that we initiate from day one. So basically, by utilizing this architecture, developers solely need to declare their deployment plan as a workflow using a YAML file in a declarative language and run it with any CI/CD or GitOps system. So we provide this flexibility when we build this environment. So for instance, when a developer actually pushes their YAML file, our platform automatically creates a service mesh and observability stack. And if also declared by the developer, we also engage auto scaling components, for example. So this way we can enhance end-to-end deployment journey, which reduces the toil and cognitive load in our day-to-day working environments. So I would also like to mention some product catalog here that we have on our TBP. Since TBP is a roof product and is composed of sub-products that work with each other coherently, developers can use declarative language to build their manifest that can contain their images to be deployed to various availability zones, different clusters with diverse configurations. And while they can also deploy this, they can also provision for example, a data store cluster, so-called Couchbase, and bind their application to such database using an application user feature that we also build in-house. So this is the great benefit of TBP concept, because we combine everything end to end coherently, and this enables the actual IDP concept. So I would like to mention a few other things. For example, we have an application platform that I already mentioned, that we can choose to deploy different applications in related with continuous delivery principles to different locations, different clusters. We also have a data store platform, which my colleagues in a moment will touch all of these, by the way, in more detail. We also have a data store platform, as I mentioned, and in this data store platform, we support various different database technologies, including like features like provisioning, and observability of the clusters, configuration of buckets, databases, or different scopes, for instance, for Couchbases. In our messaging platform, users can create new topics along with Scrum users and role bindings. And on our global inventory, not just developers, but our platform engineers and security engineers can actually collect our assets and view the details of given asset pretty much. So with that being said, guess what? We provide one console for all of these needs. So this actually means that TBP has an interface, UI interface, so-called console, and details of the applications and infrastructure components can be viewed from this console, which includes, but not limited to, observability graphs, version details of databases, Kubernetes pod status, events, or rollout strategy details, for instance. The console serves as a single point of contact for the developers and for our whole technology organization. Therefore, the need for switching between different platform UIs has been eliminated for some underlying technologies, at least, and for some we have reduced the cases that users need to go to a different platform. So basically, this actually summarizes and a brief introductory for our IDP concept, which we call as a product TBP, Trendyol Builder Platform. And with that being said, I would like to pass for application details to Erkan.
Thank you, Mete. Hello, this is Erkan. I'm a software developer in this team, ADP team. I will be talking about application delivery journey in TBP and also in Trendyol. Um, Before TBP, let's talk about before TBP. Developers are creating YAML files to deploy an application, and we are all using Kubernetes to deploy an application also. We were using YAML files to define our deployment services or something like that, and we were storing them in our GitLab repositories. As you can imagine, we were having so many YAML files in our traditional way. We write a bunch of YAML files, and as you can see, we use GitOps. So after this one, we use GitLab, GitOps, and we deploy these resources using some of the continuous delivery applications or some kind of CLIs like kubectl or Argo CD. Sorry. After deployment, we may need to see our resources, like if our pods are created or if our pods are running. We may want to see their logs or metrics, something like that. So you can see that we use different platforms to view our resources after we create them from another platform. In addition to applications, for the infrastructure resources, we were creating tickets and waiting for them to complete or some kind of flow. So that was a manual process, and this is before the TBP. After TBP is for both application and infrastructure resources. We still store our resources, YAML resources in GitLab, and we use GitOps. But we use only one YAML for an application. Before TBP, we were using so many YAML files to define all of the other resources, but with TBP, we use only one YAML file, smaller than the previous one, and we use TBP to deploy that to Kubernetes clusters. And thanks to TBP, we can see our resources created, and we can view our pods, logs, or something like that. So we use our TBP for continuous delivery tool, and also we use TBP for um, viewing our resources and bunch of tools composed together. And this is after TBP flow. And with the feature of TBP and in a close period, we will be connecting whole process with TBP, and we will create a one-line approach for users. Like developers may not, developers will not have to use GitLab to store their manifests, YAML files. They will be able to use TBP, and they can still continue to see their resources with TBP also, because current TBP flow already supports deploying and viewing resources. And with the future of TBP, developers will be able to connect the whole lifecycle of applications. Um, this is what I mean. I mean the creating application. Um, and as you can see, we are trying to connect the flow. Um, we are trying to propose a hosting experience. Uh, this is coming from a spec called Open Application Model, and TBP embraces it. Open Application Model is says that uh, applica- uh, an application related resource or file maybe stay together. Like if you have an application, put them in a file, and if you have other resources, traits, and other kind of resources, you can connect them in a single specification, and we follow it in TBP. So all you need is in a single file, in a single application, your application, other helper resources, databases, something like that. And we follow open application model. And as an example, this is an example YAML we use in Trendyol right now. Um, Developers use this YAML file every day. This YAML file, as you can see, it is 42 line. Uh, this YAML file produces so many resources with so many best practices learned in a couple of years in Trendyol. It has so many experiences and troubleshooting processes. Uh, the YAML file right there has an application and a component. As we follow open application spec, you can define your application and you can put your components. For example, you can see a Hello World component which uses Trendyol Web Service type. Trendyol Web Service type is a component type, and it's a template actually. You can imagine it as a Helm chart. We define our best practices and we take minimal inputs and I mean less parameters to produce more and bunch of YAML files. For example, the example here has image, language, traffic, and a couple of parameters here. And we use this YAML file to create almost 280 lines of YAML files, which contains a rollout definition, I mean Argo rollout, because with TBP we support canary and Willigreen deployments from day one. So we don't use deployment and we use Argo rollout by default. And it has Kubernetes services, multiple services. It has service accounts, feature service, or some kind of other resources. And it has so many best practices and configurations together. If there's a configuration every developer has to complete in their application, they don't have to do it. We just change our template and it deploys automatically to every application that use TBP. And also you see that you define your application's topology and different overrides for different environments. For example, you define your production topology to say that you will use a specific Kubernetes clusters for production. And also you can define an override policy for production. You may want to use different configurations or parameters for production environments, or you may want to use different versions for different environments. This is how you achieve it in Open Application Spec. You can also define how you deploy this application. For example, you can start deploying you can start deploying your application with stage environments, and you can sorry you can also define other workflow steps like deploy stage first and run some kind of test, and also you can also deploy production, and you can also send notification to somewhere else. This is your workflow, and um, this is an complete open application spec. Developers use it every day, and Trendyol Web Service is our components, but you see that this is a type, so you can change it. We have a couple of components. We have different types of components, like Trendyol Worker, or something else. Lastly, in addition to that one, uh, Open application model allows you to define your traits. For example, uh, we have a couple of different platform tools like rate limit or dynamic configuration or secret management. You can connect different kind of tools to your application, different kinds of tools to your application. For example, we don't put all of the platform applications to our template as a parameter. We define our template, Trendyol Web Service, and we also defined traits, which is another spec of Open Application Model. And we allow developers to put their threads into their applications, so developers can easily use other threads like platform tools, rate limit, or something else. I am trying to go to another slide, but it's not here. But anyway, and this is done for me. Mustafa, do you want to continue?
Yes. So if you want, I can share the slide that you mentioned. You can just go over it if it's okay for you. Okay. Okay, I'll continue it anyway. If Erkan gets back, I can deliver it. So, hey everyone, this is Mustafa from Application Delivery Platform team. So I'm a software engineer in Trendyol for 3.5 years. So thanks Erkan for going over the introduction about Application Delivery Platform side. So as he mentioned, our main objective is to provide a holistic experience for our builders. So that's why I'll go over the feature sets that we provided until now. So currently, in that screenshot, you see the TBP's dashboard. In that page, we tried to provide actually an overall view of builders' needs, such as metrics that they daily check out. In that dashboard, you can see the 4 key metrics in the top part. So in the left part, the user can see its all inventory items and their status actually. And also instant processes are quite important for us, so that's why we also put the instant statistics that belong to that project in the left side, so last 30 days instance. And also along with these ones, we provided quick links that they frequently visit. And finally, in the bottom side of the page, you see recent console actions. That's in that part, you can see the all actions taken for that project, and also in the above part, you see overall firing alerts that also can builders see their firing alerts and observe details about them. And finally, we put merge requests. So without visiting GitLab, they can easily see the open merge requests and take actions for them. So this that was the our dashboard page. So I'll continue with an application detail page. So as Erkan mentioned, with OAM, developers can create an application and they can track the after that, like deploying it, deploying the application. They can see the application related all data in their application detail page. Such as latest deployment information in the above part that you can see, like the we provide last sync time and last commit message, etc. That kind of information. And also we also put lots of application related quick links that they can go to see their traces, or they can redirect to GitLab repository just by one click. And also we put services cover links in that page too, so they can easily access their Swagger links. So, and also we provide health information for all clusters of the application. This is also like one of the important features that you would look for in the internal developer platforms, health information. So not just viewing or seeing the details about the application, users can also can take some actions in that page, such as we provide built-in sniff network and CPU profiling features for stage environments. So they can track the incoming and outgoing traffic through sniffing network feature, and also they can profile the CPU without writing any code, just by one click. And in the next slide, you see a pods page. It's kind of a common pod view that we are familiar from different tools such as Lens or Kubernetes. So we also list application pods in here, and they can see the containers in them. And also they can take actions such as deleting the pods and viewing pod events, etc. So one of the other features that we provide, that when you deploy an image, you would want to like revert the change, or you would want to view the revision history and roll back to previous version. And also we provide that feature in application detail page. So in that page, builders can see all the revision histories, and also they can compare the revisions with the previous ones. And as I said, with just one click, they can roll back to previous version. So that's also quite time saver one. And in that tab, finally, we also provide resource graph. As you might already know, in Argo CD, we usually use that kind of resource graph. So that's why we actually wanted to put this one in here. We thought that could also be useful, and also we got positive feedbacks about them. So you can see all application related CRDs that we have generated in just this tree view, and when you click upon them, you can view the details of that CRD. So in Trendyol, we use Argo rollouts for progressive delivery. So that's why we in TBP we create our applications with progressive delivery support, with Argo rollouts support from day zero, which means you have natively have canary and blue green deployment supports from day zero. And also you can track your delivery progress, set weights, and also perform rollout actions from that page easily. You can just retry the rollouts, promote them, or whatever that you already been using in Argo rollouts. And yeah, and also one of the crucial feature sets that we provide is our observability page. Normally we use different APM tools in Trendyol, but with that observability page, we did not want our builder or user to leave the page for viewing some metrics or logs, etc. So that's why we actually put them all into one screen, so they can easily filter their application and view view all four golden signal related charts in that page, such as throughput, error rate, that metrics that we track in our daily basis as engineers. So also we put logs section in here. So without leaving that screen just to check out Kibana or Grafana, you can just see all your logs also in that page too. So this is quite time saver one, because tracking all observability related data from different tools sometimes is quite time consuming. So this was the last thing about that page. Okay, so also we use Consul and Vault in Trendyol for our config and script management, as we previously mentioned in our other streams. So we store our configs, application configs in Consul, for instance. So that's why we also put a config and script page in here that builders can take various actions about their configs and secrets. And also they can update their config and secrets through that page. They can revert to previous config versions, so they can roll back the previous configs or secrets easily from just one screen. So that was the configuration and secret management. And finally, I want to talk a little bit about our migration journey from Argo CD to Trendyol Builder platform. Normally, migrating will be quite time consuming, because a builder has like Kubernetes CRDs, and they have to convert these CRDs into OAM definitions. So at the beginning, that could be difficult because it's kind of new thing for a new user. But it's actually quite easy to use. But you have to, you need to have some time to get used to it. So that's why we tried to solve that problem and accelerate the TBP migration process. That's why we built a migration wizard, which converts Kubernetes CRDs into OAM YAMLs. So in here, there are just 3 easy steps that they specify the Argo CD manifest repository, and we provide applications on there, and they just choose it. And when they just click the next, it will just generate the OAM definition by covering all the Kubernetes CRDs that has been managing by the Argo CD. So this might be either short or long, depending on your Kubernetes CRDs. If it's so complex, so it will be long. But this is the most optimized way to generate it, and quite easy. And finally, we also, as I mentioned, as I mentioned about our config and secrets. With that transition, we also move their all config and secrets to TBP architecture. So at the end, they do not need to do any manual operation in here. And when they just click on start, their application will be migrated from Argo CD to TBP in just in a few seconds. So that's all on my side. I'm gonna pass Koray for data store. Thank you.
Yeah, this one. I couldn't open this one beforehand. Well, you see TVP console and you see what spec we give from developers, and you see the flow. And this one explains how we connect the GitLab flow and our UI. First of all, developers define their application manifests, YAMLs, less YAMLs to their GitLab repositories. Afterwards, we track changes in that repositories with Flux, which is installed in our control plane. It's TBP control plane. There are two concepts for us: control plane and data plane. Control plane is our main components to run TBP well, and data planes are the clusters, other clusters that developers run their applications. You can think of that a developer has an API called order API. Eventually, that order API will run in a data plane, but that manifest of the order API manifest, will be stored in our control plane because we have to process it and distribute and deploy it to anywhere that developer expect. Developers define their manifest in GitLab. We track changes with flags, and when the application manifest comes to the control plane, uh, we use kubevela to distribute it to data planes. Generated manifests from our components like Trendyol Web Service will be applied to data planes. Each of one. If a developer wants to deploy their applications to multiple clusters, kubevela will do that. And on the other hand, we track the application manifests too, like kubevela, to show any kind of resources or data to developers. You see many informations in TBP console UI for an application. We collect those data with collected data with ADP collector, and that the application helps us track application changes and enrich that data with a couple of external APIs or internal ones, and we store that documents in Elasticsearch for search needs. And after that, we serve them with our ADP API, which is our main API for our team, our domain. And also, TBP console has that BFF, which handles, audits or authorization stuff. And so you see that when a developer wants to access its application from TBP console, the collected data from ADP collector is stored from ADP API. So this is for our primitive architecture for application delivery. So I believe Cora is the next for data store platform. Thanks again.
Hi, everyone. Thanks, Erkan. This is Koray Serteke, and I've been in Trendyol for almost 3 years as a software developer. Before that, I would like to give a brief introduction about database platform, data store platform. So, as you all know, that database services are one of the main backbone of nearly almost all applications. So we should keep in mind that while one of the reasons why TBP is so fascinating and development and deployment lifecycle for developers. Also, we should keep in mind that just keeping it provide the path in a secure way. So actually, one of the most gain with database data store platform is to just not to get into delay services, and one of the main goal is to provide a smooth way. And on the other hand, we have to keep in mind platform part is critical and complex part. You should just fill in the all the secure holes, and while doing that, you should also not to get stuck in development and deployment parts. So there are just in main three platform applications that we develop for TBP are Couchbase, Postgres, SQL, and Elasticsearch. Let me start with Couchbase platform. Actually, as already Erkan mentioned, when the Kubeflow already deployed OEM applications and elaborate to related custom resource, from that point, with Crossplane, we provide tracking those custom resources, and we started to spawn external services. By the way, we should keep in mind this, those Couchbase, Postgres, and Elasticsearch, also there are more on the way, are on-prem services. We manage those services ourselves. With Couchbase platform, what we provide for now for TBP, with after Crossplane custom resources, we just let to create Couchbase clusters regarding to information like just it should be multi available or just a single zone, and also detailed information related to like nodes, buckets, app users internally. And on the moreover, we also provide bucket scope collection, creating, altering, or delete operations. Also, that delete step is a crucial pattern here. We also be in a safe way not to lose data. And let me pass through another slide. Moreover, we provide observability related to Couchbase metrics regarding to memory usage and all metrics provided by Couchbase, like bucket information and the status of the VMs, clusters, health status. The next is PostgreSQL data store platform. It also supports multi-availability and detailed resource information. Again, like just say what kind of database developer created for the related application, application users, and nodes information. Again, we also support create and alter and delete operation there. Also just the extract metrics from PostgreSQL, again, like just to give inside lookup. It is the same logic for Elasticsearch platform as well. And with the Elasticsearch platform, we also see detailed information about what kind of nodes and other stuff, and internal metrics regarding to Elasticsearch in one console for the developer to track their usage and any bottleneck or any information. Last but not least, as Erkan mentioned, before and after for the TBP. Before TBP, developer just has to wait for open ticket, and for every operation or request, they have to get into cumbersome information. For now, just they can easily use what they need related to their application requirements in one YAML. That's the main benefit, main gain about the TBP, and that's the all my things to say. Now I deliver to my friend for the next slide. Okay, Bilal, you can start. Furkan, you can start for the messaging.
Thanks, Koray. Good afternoon, everyone. I hope everyone is doing well today. Thank you for joining me for this presentation. I'm Furkan, working as a platform engineer at Trendyol. And today I'm gonna talk about our messaging platform, specifically Kafka. It powers our internal services by enabling seamless communication and data processing across our organization. We have nearly 40 Kafka clusters in Trendyol, and managing these Kafka clusters introduces a significant operational challenge. It requires attention to the configuration, monitoring, maintenance, and to ensure optimal performance and reliability. To make things easier for everyone and to help our developers to focus on their work, we are building this self-service platform. Our objective is to reduce cognitive load from our developers and prevent mistakes while creating resources for configurations. We are doing that by applying policies. These policies also help ensure that developers adhere to best practices as well. By enforcing these policies, we aim to minimize the risk of misconfigurations and maintain a more stable and reliable messaging platform. Another goal of TBP is to centralize and better utilize our Kafka resources and eliminate the need of third-party tools that our developers are currently using. At this stage, we provide support for cluster overview and topic operations such as create, alter, and delete. You can see sample screenshots from the slide. Also, we are providing Scrum user operations while supporting both RBAC and ACL authorization frameworks. We also offer guides to inform our users about our platform. In the near future, we will implement observability, and in the long term, we will aim to abstract the underlying technology from our users while adding more features that help both developers and our core teams to manage Kafka resources in their daily tasks. It's gonna be a short one, and that's all from my side. Thanks for listening, and I'm passing it to the Bilal.
Thanks, Furkan. Hi, everyone. I'm Bilal. I'm working as a platform engineer at Trendyol. Today, I'm going to talk about our global inventory service at Trendyol. As you know, managing a large number of virtual machines presents significant challenges. particularly when it comes to maintaining the current information and accessing it through a central console, centralized console. At Trendyol, we have addressed this challenge by developing our own custom inventory service. As you know, that I already mentioned, there are a large number of virtual machines in our infrastructure spread out over different locations and different virtualization platforms. Such complexity requires a strong and efficient management system. Our inventory service is structured around two key components. It's the agent and the API. Agents are deployed in each region and tasked with collecting, fetching VM information from various virtualization platforms. Then they update the inventory data, which is stored on a cloud bucket. These agents are responsible of communicating with the virtualization provider itself and collecting the information for more than 40,000 virtual machines across 14 regions. Before this setup, we had only one application which acts as a single API. We were also serving the inventory data from this application before the setup. However, we were facing some problems about the availability of the application and the cases where we, for example, couldn't fetch the data from the virtualization provider. Then another reason for splitting the API and the agent into separate applications is to be able to manage the instance stacks more flexibly. In our current setup, we can overwrite, update the instance stacks over the API. Even the tag value is different or doesn't exist on the virtualization provider. API serves the data both from its database and the virtualization provider, but the priority of the database is higher than the data from the virtualization provider. API is responsible for the serving inventory request, long story short. It fetches the inventory information from a cloud bucket and synchronize these data with the database according to the difference between these two sources. This screenshot shows the visualization of the data which is fetched from our API. So that was a short part, actually. Thank you for listening. That was all from me. Please feel free to ask anything you wonder at the Q&A session. I guess it's time for the Q&A.
Actually, before Q&A, we have metrics to show really quick about the product. Sure, no problem. So we talked about great features, great developments, and good concepts about developer experiences. So this is the time actually we validate how our product turned out in terms of the adaptation and the metrics. So we would like to share, I would like to share a few metrics that I can share in this session. So the first one is the adaptation. So from our service catalog, based on that, we are actually maintaining and using three different methodologies for our continuous delivery. So TBP is one of them, Trendyol Builder Platform, as my colleagues has mentioned already. We also use Argo CD and kubectl. So these are the practices that our developers has already adopted. So from this pie chart, we can see actually that TBP adaptation has became 35% internally, where Argo CD is 34%, and kubectl is 30%. And in the next slide, actually, I can show you the historical adaptation, which makes a little bit more sense probably to many of you. So over the last 2 months, since we took this screenshot, we can see a significant plunge in Argo CD adaptation in our organization. It reduced from 50% all the way down to 35%, whereas TBP has skyrocketed from 12.5% adaptation up to 33.9%. We also see a drop in kubectl adaptation. So this graph proves us that TBP concept is definitely covering a huge gap that we identified in our organization. So let me jump into the next one, and this is the last metric that I would like to show. This is the reasoning, one of the reasons why this historical graph turned out the way that it was. Besides what my colleagues has already explained to you, this is one metric that also outlines that, and this is the average initial sync time on different CD platforms that we currently have. The one on the right is the Argo CD. The one on the left is obviously the TBP. And as you can see and imagine, there's a huge difference between the two, 1.9 seconds versus 7 minutes. This definitely affects team cycle times and development efforts. And those, by the way, those DORA metrics will be covered in our next developer experience episode. I can also mention that. And for those who are interested to see those metrics, I would definitely invite you to join to the next session. And now actually is the time to go into the Q&A. So I think we have 2 questions The first one was from Majid, and he actually asked, can you explain about running tests for TBP? So what kind of tests probably we are currently running or developers can run through this platform, if there's any, I'm assuming. So maybe from my colleagues who would like to answer this question.
I can answer for the application delivery side. Maybe my colleagues will be add some other info. Actually, for instance, we use, of course, we try to apply different test practices because we cover all of the technology team at Trendyol. So breaking some stuff will be killer for our side. So that's why, for instance, we use end-to-end tests to provide the stability of our queue template catalog actually. So if and also we apply different integration tests to test our platform better. So these were the ones that first came to my mind.
Okay.
Yes, Mustafa. Also for the data store part, we also apply end-to-end test to. Moreover, we also apply end-to-end test for all the requirements are handled properly.
Okay, and
as well.
Perfect. Thank you so much. Let me jump into the next question really quick. Farooq has asked, what are the supported programming languages?
So maybe we can, it might be good to elaborate programming languages things in here. Maybe I can or mention about OIM part. It is not related to programming languages. It's totally GitOps things.
Yeah, sure. What we offer is deploying an application, a workload, a container image. You can write your application in any language. We just need your container image. You can build your container image in many different ways. You can use Python, Golang, anyone. shell script, anything. And once you containerized it, you can deploy it, run it, and see it in your TBP page. So it doesn't matter if there's a container image.
Yep, perfect. Thank you so much, Erkan, addressing that question. So let's jump into the last question that we have from Majid again. Have Trendyol developed as an open source project? So he's asking whether this is an open source project or not.
If he's asking about like our like as a Trendyol open source, I think Mehmet, I mean, link. So this is the correct one. You can check out. Of course, yeah, we do have lots of open source projects, like have been used by other developers too, and also we, for instance, use one of these projects. We have our UI kit, which is Baklava, and in TBP we use it also in our in-house solution. And if you ask about like the TBP as an open source, it's not open source right now, so we'll see. So that's all.
Okay, and one more question came from Majid again. Is it compatible with clouds such as AWS?
I can answer for the data store platform part. As I mentioned, we are just managing on-prem, not Couchbases or RDBS on AWSs. So actually, it's not in the way like just a compatibility with AWS. It is like just managing Trendyol on-prem services to the developer.
For the application side, in theory it is, yes, but as you can imagine, we developed all of this for Trendyol. So there are some kind of Trendyol standards or platform, like we use Istio or any other tools everywhere. So we have some kind of dependencies like Argo rollout or some other tools I don't mention. In theory, yes, but we have to prepare cloud for us, for our templates environments. But in today's world, it is not.
Okay, perfect. Thanks for answering that. I'm assuming there's no other question. So perhaps we can end this live session here. Thank you for all joining and being with us and listening our great improvements. And also, I would like to thank my colleagues sparing the time and the effort for this presentation. So hope to see you in another session, another episode. Thank you so much.
Thank you.